Now, some of the things they'll ask you to use simultaneous equations for, or rather matrices for, is in these type of situations where you've got a variable k, and they want to see that they want to find out what values of k will provide no solutions, an infinite amount of solutions, or one solution, a unique solution as they call it. So for question 16, what you need to do here is show that the discriminant equals 0, and then prove or determine how many solutions or values of k for either 0 or infinite sum of solutions algebraically. Now remember, if the gradients are two equations, so we've got two equations here, if their gradients are the same, but the y-intercepts are not the same, then there's 0 solutions because the lines are parallel. If the gradients are the same and the y-intercepts are the same, then we've got an infinite number of solutions because one line exists on top of the other line. So they occupy the same space, so there's always a solution. Alright, let's have a look. So remember, we want to find a discriminant. We make up a matrix using these four numbers here. Or sorry, our four coefficients. So we'll have 4, -6, -2, and 3. And that equals A. And so we're going to say the determinant of A equals 4 times 3 minus -2 times -6. We end up with 12 minus 12, so we end up with 0. Okay, so now we've got to prove it algebraically. So to do that, we want to express our equations in terms of y, and from there see what we need to do to satisfy our conditions over on the left. So we've got 4x minus 6y equals 8. Rearrange this for -6y equals 8 minus 4x. So this divides by -6, so we end up with y equals -3 over 2 plus 2 over 3x. So we do the same thing with the other equation. So we've got -2x plus 3y equals k. And from there we've got 3y equals k plus 2x, divide both sides by 3, so we've got y equals 1 over 3k plus 2 over 3x. So, let's have a look. The gradient is 2 over 3, the gradient here is 2 over 3. Okay, so the gradients are the same. So then we check out our y-intercepts. So our y-intercept here is -2 on 3, and our y-intercept here is 1 over 3. Okay, so 1 over 3k. So then our value of k, so if we have the same y-intercept, then we've got an infinite number of solutions. So for an infinite number of solutions, k has to equal -2, because then we'll have -2 times 1 over 3 equals -2 over 3. If we want no solutions, then k can equal anything apart from -2. So we'd end up with our value there. So that's how we go about solving that. So for question 16, we show that a determinant is 0. Because you know it's 0, we solve it algebraically. So we set them up. Now, if we were finding this, if our determinant wasn't equal to 0, well then whatever made k 0 would be our conditions for one solution. But we'll have a look at that in another video.